In this module, we will examine protocol communication to include normal and abnormal traffic. So what we're going to do is we're going to cover the following: exploring the IP header and analyzing network connections. What happens when we connect and send data back and forth in a network? So when we look here, we have the IP header as it appears in the middle and bottom window of the Wireshark tool. As it shows, these are the components of the IP header, and the encapsulated protocol is TCP. We know the encapsulated protocol because of the type field from within the IP header. This is located at the 9th byte offset. That is, if you count from the start of the IP header with the count of 0, because this is computers, and computers always start at 0, and count 9 steps, the decimal 6 indicates the protocol type of TCP. As we discussed before, we have ICMP protocol type is 1, UDP protocol type is decimal 17, hexadecimal 11, and TCP is 6. So we're not going to spend too much time on this because we've covered this, but this is a slide for your review. What we have here, as we said, ICMP is a 1, TCP is a 6, and UDP is a 17, but we can't represent 17 in hexadecimal, so we represent it with an 11. And again, that's the 9th byte offset of the packet header when you start counting from the 4 and the 5, the 45. With TCP, we have guarantee of reliability, and we get this from the control bits or flags of communication. It's connection oriented, as we said. The connection is interpreted as a stream, and that means it's interpreted by the application and not TCP. That's very powerful. That's why when we do that follow the stream, we have the entire sequence of the connection. Now, as we look at the diagram, the key here is the flags. In this packet, the ACK flag is set, as you see here. This means that a packet has been received and it's acknowledging that packet. These flags all have a specific meaning within the connection, and is what we want to understand when it comes to hacking, security, and also intrusion analysis. The flags are as follows. U is for urgent. That means the urgent pointer is set and this data is urgent. A is for acknowledgement, or ACK, which we've already discussed. We're acknowledging something that was sent. Push has data within the packet. Reset, abnormal close of a connection. SYN is open a connection with me. Some like to refer to that as the hello. And then finally, finish is the normal close of a connection. These are the 6 main flags of TCP. By understanding these flags, you can identify what's taking place in the network, both from a standpoint of normal traffic and abnormal traffic. This slide shows the connection for each TCP communication, and that is what we call the three-way handshake. And this is shown here both in the diagram and also in the image from the packet capture in Wireshark. It's a SYN ACK followed by an ACK. Now remember, the first SYN or synchronize says open a connection with me. The acknowledgement is acknowledging that open a connection request. The second step SYN is from the receiver, because the receiver has to open up their own side of the connection. This is why TCP is full duplex and either side can send or receive at the same time. And the final act is the acknowledgement of the synchronize or the connection request received from the receiver. TCP connection close. Remember, we had 3 steps to open the connection. It takes 4 steps to close the connection. This is because we have to close each side of the connection. So here we have in the diagram a FIN-ACK, which means please acknowledge my finish request. And then the acknowledgement returned means I acknowledge your finish request. And the FIN-ACK again is the close of the other side of the connection. So remember, both sides of the connection have to close. This is so one side can close while another side still has data to send. Very important that we allow both sides to send their complete data. One side might be sending 1,000 bytes, for instance, and the other side sending 100. So it's not really good engineering design to require the person with the 100 bytes to leave their connection open until the 1,000 bytes are transferred. And that's why each side can close its own connection. So as you look here in the image taken from Wireshark, we see a SYN, a SYN-ACK, and an ACK in packet 18, 21, and 22. And then immediately we'll close 23 through 26. So that's the three-way handshake followed by the four-step close. Now we got TCP connection reset. When something goes wrong within TCP, a reset is used to tear down a connection. If you're seeing a large number of resets on the network, this could be an indication something's not right on the network. In most cases, it is something not right on the network because it's an abnormal close. It's an actual example you see when somebody's trying to connect to a service that's not there. If they keep trying to connect to it, TCP will respond with a reset. You'll see an abnormal amount of resets in the actual packet capture. It's all in the packet. So as you look at this image, you can see the flags that the packet has set. So what is wrong here? This packet has the following flags that are set: the fin, the push, and the urgent. So the fin is a finish or a close of a connection, push is data, and urgent is the urgent pointer set. So let's think of this logically. With our analysis, we know fin is a normal close and push is data, and urgent is the urgent pointer set. Do you think it would be normal to send data in the same packet that is closing a connection? Remember, when we close the connection, we're just telling the receiving side we want to close. We send a fin flag with the ACK flag set. All we showed you in the slide was the fin and the ACK flag set. So what about having data or the push flag set in a closed packet? Hopefully you're thinking this is not normal. It is not normal. That's good. This is an abnormal packet. In fact, it's a crafted packet. And since it's a crafted packet, it's an abnormal packet on the network. It's actually the signature of one of the most popular hacking tools that is free and open source on the market, created by a guy that goes by the name of Theodore, and that is Nmap. And this is what we call the XMIS scan of Nmap. So in Nmap, it actually sets three flags: the fin, the push, and the urgent. So now looking at this packet, we know somebody has conducted an XMIS scan against wherever this packet is directed. That's the power of understanding what's normal and abnormal on our network. So in this section, we explored the IP header and how to identify the encapsulated protocol. We reviewed the network connections, and more importantly, the communication control bits or flags of TCP. Now you have enough knowledge and enough skill to review abnormal traffic data and some basic attacks using Wireshark. So next up, we're going to take those skills and we're going to apply them and analyze attack communications.